Section 7.1 is the beginning lesson for Chapter 7 on systems of equations, and today's lesson will be solving systems of equations by graphing. Now, a system of linear equations is when you have two or more linear equations that have the same two variables. So two equations, two variables. The solution is an ordered pair, and when we solve by graphing, it will be the ordered pair where these two lines intersect. So remember, a linear equation makes a straight line. So for a system of linear equations where the two lines cross, that ordered pair is the solution for the system. So like I said, today we're going to solve by graphing. And here are the steps to solving by graphing. First, you're going to write the equation in slope-intercept form. And then you're going to graph your line. And then you're going to do the same thing for the second equation. You're going to make sure it's in slope-intercept form and then graph that line. And finally, your last step is to indicate the ordered pair where the two lines cross. And that ordered pair, the x-coordinate and the y-coordinate, are the solution. So the solution is the point where the two lines intersect. So first, we're going to start with this system. We have two equations, y equals 2x plus 1 and y equals negative x minus 2. Both of these are already in slope-intercept form, so they are ready to graph. So you're going to start by making your x and y axis on a coordinate plane. And when we graph these lines today, we want to make sure our line is as straight and as exact as possible because we're looking for a specific point where these two lines cross. So we're going to start with the first line. Notice that the y-intercept is 1. So we graph the point 0, 1, and that is on the y-axis. And the slope of that line is 2 over 1. So we rise up 2, run to the right one time. And since we want our line to be as exact as possible, we're going to do that multiple times. So up 2, right 1, up 2, right 1. And then we're going to go in the other direction and go down 2, left 1. Because we don't know exactly where these two lines will cross. So we want to make our lines as exact as possible, especially starting out. And then when you have a bunch of points, you might want to take a ruler for this lesson just to make our lines straight and connect them with a straight line. So there is our first line for our system. And then we're going to graph our second line. And it is the equation y equals negative x minus 2. The y-intercept is at negative 2. So we got a negative 2 on the y-axis. The slope is negative 1 over 1. So that means I'm going to go down 1 to the right 1. And then I'm going to go in the opposite direction, up 1, left 1, multiple times. And we can see now where the red line and the blue line are going to cross each other. So after we graph our second line, we look to see where the two lines intersect each other, and they're intersecting at this coordinate right here, which is the ordered pair negative 1, negative 1. So we write down the ordered pair where we're intersecting, and that is the solution to the system of equations. So we're looking to see where the two lines intersect, and that ordered pair is our solution. So make sure you write the solution, because if you don't include the ordered pair, you're not telling the answer. So the ordered pair where they cross is the answer. So let's graph another example. Okay, this time we have the equations y equals negative x plus 3 and y equals 4x minus 7. Notice these are both in slope-intercept form already, so they are ready to graph. So draw your x and y axis on a coordinate plane. And if I'm noticing, this one needs to go all the way down to negative 7. So this one needs to be kind of a tall graph. So I'm going to make sure I give myself plenty of room for that. Okay, so for the first one, the equation is y equals negative x plus 3. My y-intercept is at 3 on the y-axis. And the slope is negative 1 over 1. So I'm going to go down 1 and go to the right 1. And I'm going to do that multiple times because, again, I want to make sure my line is as straight as possible so that I can tell exactly where these two lines are meant to intersect. So there's my first line. Okay, and the second line is the equation y equals 4x minus 7. My y-intercept is at negative 7, so I go to negative 7 on the y-axis. 1, 2, 3, 4, 5, 6, 7. It's about right there. And the slope of this line will be positive 4 over 1. So I will rise up 4 and run to the right 1. So I'm going to go up 4, right 1, do it again, and I can already see I'm going to intersect right there. I barely have room for one more point. So I connect those points with a straight line. And remember that the ordered pair solution is where these two lines cross. So these two lines are crossing right here at the point 2, 1. Positive 2, positive 1. So the solution is the point where the two lines intersect. So far, all of our lines have already been in slope-intercept form. So we need to see a few examples to where they are not yet in slope-intercept form. So that's what we're going to do next with this next example. All right, so both of these equations are going to take a little bit of work to get them in slope-intercept form. So I'm going to start with the first one and get everything done for it, including graphing the line before I do my second equation. That just sometimes helps us keep from getting the two lines confused on what we're doing for which one. So I like to do everything for the first line, including all the graphing, and then move to the second line. So for x plus 2y equals 7, I want to solve it for y to get it to look like y equals mx plus b. So I'm going to subtract 1x from both sides. And then I get 2y equals negative 1x plus 7. And then I divide everything by 2. So y equals negative 1/2 x plus 7 over 2. Now, we're not going to let these fractions scare us or anything like that. We're just going to work them out just the best we can. 7 over 2 is the same number as 3.5 as a mixed number. So my y-intercept is 3.5. So when I graph this line, I'm going to go to 3.5, which is up 3 whole spaces, and then go up 1 more half a space on the y-axis. And then my slope is down 1 to the right 2, negative 1 over 2. So I'm going to go down 1 whole, which puts me at 2.5 on the y-axis, and then run to the right 2 spaces. So again, down 1 whole to the right 2. And I'm going to do that multiple times so that I can have my line as exact as possible. I'm also going to go in the opposite direction, up 1, left 2, multiple times. And I'm going to make my line as straight as possible. Catch all of my points. You might want a little crooked, but it's okay. So again, if you have fractions for your y-intercept, just kind of estimate on the y-axis where that number will be. My next equation is also needs to be put in slope-intercept form. So we did the equation 3x minus 2y equals 5. I'm going to do everything for this line in red. I did everything for the first one in blue. I'll do this one in red. So I will subtract 3x on both sides. And then I get negative 2y equals negative 3x plus 5. And then I divide all of my terms by negative 2 to get y by itself. And simplify, I got to fix my signs. I get a positive 3 over 2x minus 5 over 2. And negative 5 over 2 is the same thing as negative 2.5 as a mixed number. So I will go on my y-axis down 2 and down a half more to be at negative 2.5. And then my slope for this line is 3 over 2. So I will rise up 3, 1, 2, 3, and run to the right 2 spaces. I'm going to do it again. Up 1, 2, 3, to the right 2. And I see I'm going to cross somewhere between those red dots. So there's my red line. And I am crossing these two right here at this green point. So my solution is that ordered pair for this system of equations, and that is the point positive 3, positive 2. So that is my solution. So if we have fractions for our, we're used to having fractions for our slopes because we have a rise and a run. But if you have a fraction for your y-intercept, just estimate on the y-axis where that is. Turn it to a mixed number if you need to so that you know where that number is. All right, so there we've done 3 examples. Let's do one more. We're going to skip to the you try problem. All right, so the first one says negative x plus 2y equals 3. That does not look like slope-intercept form, so that's the first thing that we're going to do here is make that first equation look like y equals mx plus b. So negative x plus 2y equals 3. I want to get y by itself, so I'm going to add x everywhere. So 2y equals 1x plus 3. I will divide everything by 2 now. So y equals 1/2 x plus 3 over 2. And 3 over 2 is the same thing as 1.5 as a mixed number. So now that it's in slope-intercept form, I graph my x and y axis on my graph paper. And like I said, 3 over 2 is 1.5, so I go up 1 and up a half more on the y-axis. My slope is positive 1 over 2, so I go up 1 to the right 2. And remember, I'm still halfway between because my y-intercept was a fraction. And then I'm going to go the opposite direction. And there's my first line. Mine's a little crooked, but I think you can tell where it's supposed to go. So there's my red line. And then my second line is also not yet in slope-intercept form. I'm going to do this one in blue. 2x plus y equals 4. And all I have to do to get this one in slope-intercept form is 2x. So y equals negative 2x plus 4. So positive 4 on the y-axis is my y-intercept. And that slope tells me to go down 2 to the right 1. So down 2, right 1, down 2, right 1. I can already tell where that's going to intersect. So I'm going to draw my blue line. Goes through right there. And the ordered pair for this intersection is the point 1, 2. So make sure you write your ordered pair for your solution, because the solution is where these two lines intersect, and you need an ordered pair. So hopefully this has helped you see how to graph systems of equations and solve them by graphing. So have a nice day.